Hey everybody, welcome back. This is going to be your video for May 4th. So you want to start a brand new sheet of paper, go ahead at the top, label it or title it 5-4, write down these problems, try the homeworks, and then you guys will upload a picture on the Google Doc, send it to me for full participation points. Hopefully it makes sense, and if there's something you're struggling with or whatever, go ahead and make sure you contact me through Google Hangouts, Google Meet. We can do a little virtual meeting or something to help you out. But hopefully this lesson goes pretty smooth. Last week we solved equations with using square roots because we had a power of 2. Today we're going to be doing the same thing, except now we're going to see parentheses in our equations. So let's see how we can kind of do these a little differently. In order to solve an equation, we want to get the variable by itself because that tells us the number or numbers that make the equation true. But when there are parentheses, you cannot get rid of any of the numbers inside the parentheses until you've broken free from them. And we got to get rid of that squared then as our first step. So when we see x plus 1 in parentheses or quantity squared equals 25, we cannot minus 1 on each side. That'd be illegal because it's trapped inside the parentheses. So in order to break free from that, we got to get rid of squared first. Now the opposite of squared is square root. So I will take the square roots of both sides. Now, I left something off on purpose. Hopefully you know what I forgot right now. When you take the square root to solve an algebraic equation, you have to put plus or minus on the square root with the number side. So I forgot a plus or minus right there on purpose. So usually I'd space it out a little more to put that plus or minus in front, but I gotta kind of squeeze it in right there. So on the left side, the square root and the squared cancel. So this and this go away, we're left with just x plus 1, and you don't need the parentheses, equals, it's plus or minus, and the square root of 25 is perfect. It means it's not a square root anymore, it's just the number 5. Now if you ever have a plus or a minus in your problem and you're not done, you probably just want to set up 2 different equations because x plus 1 is allowed to equal positive 5, but x plus 1 is also allowed to equal negative 5, and you can solve them separately. Now both equations use the same math, you just get different answers. Minus 1 to get rid of plus 1 on both sides gives me x equals 4. Minus 1 on both sides gives me x equals negative 6, and I am done. Now, if you don't feel confident, what you're allowed to do at this point to check your answers is plug them back in, and let's see if they both work. Let's plug in the number 4 to see if it works. 4 plus 1 makes a total of 5, and 5 squared equals 25. So yep, that's the correct answer. Let's try negative 6 and see if it works. Well, negative 6 plus 1 makes a total of negative 5. And if I took negative 5 and squared it, which is negative 5 times himself, it also equals 25. So it is a correct answer too. So what we're seeing today is whenever we use square root and we have to put plus or minus, we're going to be getting 2 solutions. They both will work. Let's try another one with a little bit more in the parentheses now. So we got parentheses of 2x minus 3 squared equals 81. Well, our first step would be is to get rid of the squared so we can work inside that parentheses. Now, normally I like to rewrite it, but in order to save time, you can put the square roots right in the original problem. You take the square root of the left side, don't forget your plus or minus, and square root the right side. On the left side, the squared and the square root cancel. You have 2x minus 3, and on the right side, again, square root of 81 is perfect. It's plus or minus, square root of 81 is 9. Now, when a square root is perfect, it's not a decimal, it's not even a square root or anything like that, it's just a regular number. Those are the ones maybe we had in middle school. But now, you're not done with your problem and you got a plus or minus. So my suggestion is, when it's just a number like that, set up 2 different equations. I can set up the equation 2x minus 3 is allowed to equal the positive 9, but there's another equation that 2x minus 3 can equal, and it's negative 9. Remember that plus or minus sign represents positive 9 and negative 9. So now I'm going to solve them using the same math steps. I'm just going to get different answers. The first thing I should do here is add 3 on both sides. So you can show a plus 3, cross it off, and a plus 3. Or if you feel comfortable doing that mentally, you can write down 2x equals 12. Same thing with the next step. To get rid of this 2, you divide by 2. You can write down divide by 2, divide by 2, or if you feel comfortable doing that mentally, the 2's would cancel there, and when you divide by 2, you get 6. That's one of my solutions. Now, I'll do the same math of add 3 and divide by 2, just get different outcomes. When I add 3, I'll have 2x equals negative 6. And when I divide 2, I get x equals negative 3. Again, you can plug them back in and see if they work. 6. 2 times 6 is 12. Minus 3 is 9. Squared is 81. Let's try negative 3. 2 times negative 3 is negative 6. Minus 3 is negative 9. Squared is 81. So they both work out. All right, last example of the day, we're going to see that all the square roots don't have to be nice in these parentheses problems, though. And how can we combat those or get final answers? And there's actually 2 different ways we can write our answers. So we're going to show that now. So number 3, we're going to have parentheses x minus 4 squared equals 20. Your first step would be no different. You see a parentheses and a squared, and you're like, I can't do anything inside that parentheses until I break free from it, so I got to get rid of the squared. So I'll square root both sides, and I forgot something on purpose. Please remember on your number side, you need plus or minus. But when I write down x minus 4 equals, because they cancel on the left side, I think to myself, plus or minus the square root of 20. That's not a perfect square root. It's not one I know from middle school. So there's 2 different ways we could do this problem. We could do our answer in radical form. That's kind of a little nicer in math. Or we could use our calculator and do decimals. Let's do radical form first. So if I wanted a radical form answer, I would take my square root of 20 and I would not use a calculator. I would just try to break it up and see if pairs come out as singles like we did back in our radical chapter. So I'll do a little scratch work over here. Square root of 20 is 2 times 10 is 2 times 5. A pair of 2's would break out of the square roots and the 5 would stay trapped. So now I have x minus 4 is equal to plus or minus 2 rad 5. But math people at this point say that you shouldn't use 2 different equations because that's going to be kind of like quote-unquote ugly anyways. So all they do is they isolate x. And I'm going to show this step where a lot of times if it's just a regular number, I would just say it out loud. But in order to get rid of minus 4, you plus 4 on each side. Now on the left side, they cancel. So you just have x equals. And on the right side, they're not considered to be like terms, so you can't really add or subtract them and make like a new answer. You just put them side by side. And math people say, put your regular or whole number first. So the positive 4 I would put first, and then positive or negative, which can represent plus or minus, 2 rad 5. And even though it looks like you have one answer, you actually have 2 different answers. One answer is 4 plus 2 rad 5, and one answer is 4 minus 2 rad 5, leaving you with 2 solutions. Now, it's a lot harder to check that one. I wouldn't say check it, just trust your math. But the other way is decimals. We're going to take this, and we're going to write x minus 4 equals plus or minus, but we're going to take out our calculator and do the square root of 20. Now, when you do the square root of 20 in your calculator, or cell phone calculator, or whatever, you're going to get a long decimal. Well, you want to round, and normally we round to the 10th place, which is one place or digit after the decimal. So when you round correctly, you would round to 4.5. Well, this is a time where you can actually plus or minus them, so my suggestion is write two different equations. I would say x minus 4 could equal positive 4.5, and x minus 4 could equal negative 4.5, and I solve them separately. Now, same thing over here. We always get rid of minus 4 by plus 4. So you could plus 4, and you get x equals 8.5. And over here, you could plus 4, and you would get x equals negative 0.5. Now, the cool thing about these answers is they're actually the same. If you took out your calculator and you put 4 plus 2 square root of 5 in your calculator, you typed it all in, you would get 8.5. If you did 4 minus 2 square root of 5, you would get negative 0.5. So even though the answers look different, they are the same. There's just two different ways of going about it. Radical answers are called exact answers because you never rounded or used decimals. But obviously if you use decimals, that's a rounded value. It's really close to the correct answer, but since we rounded, it's technically not the exact answer. All right, I hope today went pretty smooth. You guys are gonna have 3 problems exactly like those. On number 3, you're gonna go ahead and I want a radical and a decimal answer, just like I have. Let me zoom this in. It's a little nicer, there you go. All right, so number 3, you want 2 different types of answers, just like my number 3. Good luck, and let me know if you need any help. It's your boy, Mr. Pete.